All right, so this is to help you guys out with the egg drop thing, and then basically it says that we're going to assume that the average force, right, that the average force to break an egg is 25 newtons, and then we also got the mass of an egg. What did we say the mass of the egg was? I forget exactly. But anyway, well, while I get the mass of the egg, so we know that, and basically we can use, right? Okay. So feel free to look up to Google then the mass of an egg. That's fine. You can Google the mass of an egg. I'm all right with that. So here we go. I can Google what's the mass of an egg. So average mass of an egg, so a large egg, 56.7 grams. So that's 0.0567. So 0.0567 kilograms, I'll say. Like again, whatever one you used. If you used a medium egg, you can use that. Okay. And so we want to use then this F net delta T is equal to mv prime minus mv naught. But the question is, okay, now what, okay, I got this, I got the mass. What about these? What am I going to plug in for these? So here's the thing that I'm going to say is you want to split this into two parts. So you've got the drop, right? You make the drop. So you make the drop, and then just before it hits the ground, just before the egg hits the ground, that's going to be one part. So from when you let go to just before it hits the ground, that's one part right there. And then the other part is what I call the break. So, and that's okay. The thing's just about the egg's just about to hit the ground, and boom, it splatters. So those are the two parts there. So with this just before it's about to hit the ground, you can basically do a Vovat off of this, right? So you can do so if you start here, so we can do well, the acceleration is going to be down, right? This is hopefully you know the acceleration. It's free fall, right? It's free fall. You got this, so your displacement goes down as well. Hopefully, we're talking about dropping the egg, so what's the initial velocity going to be if we're dropping the egg? 0. Yeah, the initial velocity is going to be 0. And then the egg is going to have some velocity just before hitting the ground as well. So here, this is the velocity just before hitting the ground. So I'll call this V. You know what? I'll call it V. Oh, I'll call it V1 for this is the velocity at the end of part 1. And then so okay. So yeah, there's that. So it's V1, right? And you can write out a Vovat, and hopefully you can solve then for V1. So you write out a Vovat. It's free fall, so hopefully you'll be able to solve this, and you can find out what V1 is. Now for part 2 is during the break. So again, it's just before the egg is about to hit the ground. That's the initial moment, and then the final moment is the break, right? So in other words, my final moment here, let me move this a little bit. So my final moment for part 1 is going to be the same moment as my initial moment for part 2. So this is now my initial moment for part 2. So that's V1 right there. And then at the end, if we're talking about after the break, what does the egg look like after the break? Right? Splat. And yes, exactly, motionless, right? So V1 is going to be whatever number you get here. right? V1 is going to be whatever number you get here. But here, this, V2, I'll call it, that means then this is going to be, this would actually be V2 minus V1 here, right? Well, V2 is just going to be 0 because it's, you know, it's splattered right there. And so that should solve your problem then, because now you'll know V1, you've calculated over here in part 1, and then you know V2. I'm not going to repeat it again because that's for you to do, and you should be able to then solve for delta t. So hopefully that helps. Okay, awesome. So, all right, now I'm going to stop recording here.